Pajarito. Osvaldo. Aquí. Fernando. Aquí. Gabriel. Jimena.
Aquí.
Andrea. Fernando. Aquí. Gisela.
Aquí.
Sebastián. Marcos. Aquí. Milan.
Aquí.
Daniel.
Pica en el medio como la Daniel.
Daniel.
Aquí.
Oscar. Aquí. Carlos. Aquí. José Miguel. Aquí. María José. María José. Chelsea. Sofía. Sebastián. López. Bruno. Rodrigo. Joel. Paulo. Andrea. Marcelo. Joana. Paula. Sofía.
No vino.
Mariano.
¿Mariano?
No.
No vino.
María Isabel. Rafael. Novelia. Daniel.
Acá.
Yo. Okay. Fine, ready?
Qué bueno.
Ready?
Yes, we are ready from the beginning.
Thank you.
De ahora en adelante van a ser puras o sea, relacionado.
Se lo guía.
Así se llama la materia.
Fine. Okay. Listen. Okay. The next topic is called higher derivatives.
No.
Profe Mariano. Tiene que pasar, bro. ¿Quieres otra clase? Buenas noches.
Sofía miembro de... Ay, qué rápido.
Era un rapidín, nada
Hey, Mariano, ¿por qué estás tan despejado?
Fine. Okay, the topic is called higher derivatives. In this case, this is also going to be in the quiz on Friday. Okay, this one along with the previous one. This topic is not complicated, but it's a little more than the last one. Okay, so try to pay attention. In this one, for example, as an introduction, you know that when you get the derivative of something, of a function, I'm waiting. Yeah. Okay. When you get the derivative of a function, the answer is also a function. So in this case, then it's possible to obtain a second, third, or fourth derivative, for example. But the idea is the same. We're going to apply the same rules that we already know. We're just going to keep differentiating until you obtain what you want to find, or the third or the fourth derivative, or so on. So as an example, here, the question is find the fourth derivative of the function y equal to 5x squared minus e to the 2x. So if I want to find the first derivative, before that, do I need to rewrite anything here?
No.
No. Okay, so first derivative, y prime. Tell me, 5x squared derivative? 10x. Derivative of e to the 2x, this is chain rule.
Minus 2
Minus 2 times e to the 2x. Very good.
Nice.
So the derivative of 2x is 2, derivative of e to the 2x is e to the 2x. Okay? That's the first derivative. Yeah. Chain rule. 2x derivative is 2. E to the 2x is e to the 2x. Same derivative.
Then the next, then...
Yeah. Second derivative, double prime. We're going to use double prime for that. Find the derivative. 10x. Derivative of this? Just 10. Derivative of minus 2 e to 2x. Again, chain rule. Minus 4x 2x. Not 4x, just 4.
Ah, no, yes, 2, 4.
Because it's 2x, derivative is 2, times 2 is 4.
Vamos por la tercera cosa, venga.
Yeah. Then, third derivative will be y triple prime,
Minus 8.
10 derivative, 0, we don't print. Derivative of this, minus a e to the 2x, okay? That's the third derivative. And the fourth derivative, instead of using prime again, we're going to use now the numbers. Well, sometimes you can use Roman numbers, sometimes we use the normal number with parentheses. In this case, I prefer using the number with parentheses. Instead of using 4 prime, we use the number 4. Or you can use Roman numbers, also fine. Derivative of that will be 2x. Okay, and that will be the last one for this exercise.
Perfect.
Okay, so that's basically the idea. The idea of this will be to find the derivatives of the previous one until you have what you're looking for. In this case, which is the fourth derivative. Okay? Questions?
¿Es algo necesario que find like
The what?
o sea, por ejemplo, la altura no está
E to the x is e to the x. What? Finding this? Well, mostly for applications we're going to find into the second derivative, mostly. For what? For example, in your project on the first partial, you got the second derivative and acceleration. Okay? But to find the third or the fourth derivative, we're going to use that to then generalize a formula for all derivatives, which is called the end derivative. We'll see that in a moment. Okay? But the most, let's say, real application will be to find into the second. The idea is the same. Okay. This is just a notation. Remember that if I want to represent first derivative is just a single prime, double second derivative is double prime, third derivative triple prime. From the fourth derivative onwards, we're going to start using numbers. And we're also going to find the end derivative. What's the end derivative? It's going to be basically at the formula that is going to generalize all derivatives. Okay, so we'll see that in a moment. Yeah? Okay, another example. Let's find the third derivative. Okay, that one. Let's say we have f of x equal to ln of 2x minus 2 sine of 2x plus the square root of 2x. In this case, before I start, can I rewrite? Do I need to rewrite anything?
Yes.
Which one? Well, for the ln you could rewrite by separating, or you can leave it like that and just chain rule. So will be fine. Let's leave it like that, so we don't have to remove terrible. 2x minus 2 sine of 2x, but I need to rewrite that one. So it's 2x to the what? The 1. Okay? Now, yeah.
You can rewrite log of 2 and log of
Yeah, you can. You can do that if you want to, but I want to leave it like that for this, so we can use chain rule to practice. Okay, but yeah, you can do it and that's will be the same. Okay, you have ln of 2x. If I want to use chain rule to solve that, what do I do? This and this. So 2x derivative is 2 times 1 over 2x minus, again, chain rule. You have the 2, you leave the 2, but derivative of 2x, 2 times 2, 4. Derivative of sine, cosine. Plus 2x derivative, 2 times derivative of everything to the 1/2, 1/2, 2x to the minus 1/2. Okay? That's the first derivative, but since I want to find a second and then third and so on, I need to rewrite. Simplify and rewrite. So, still first derivative, but the 2 cancel. What? What? 1 over x. Minus 4 cosine 2x plus, you cancel this, you have 2x to that minus 1/2. Okay? We're going to leave the powers negative because if I want to find the derivative, I need to use the powers, not the fraction. Okay? Until the end is when you're going to rewrite. But here, we're going to leave it like that. Second derivative.
Minus 1x minus 2.
Minus x minus 2. Then this. You have the minus 4. Derivative will be 8. Derivative of cosine. Minus sine. So it becomes positive 2x. Plus derivative 2 times minus 1/2 2x to that minus 3/2. Yeah? Yeah. Do I need to rewrite that?
Yes.
Yeah. We leave this one like it is. We leave this one also. And we simplify this. So it's minus 2x minus 3/2. Yeah? By the way, I cancel this with this one, not with this one, because this one belongs to what is inside the power. So I cancel these two because they are the coefficient.
Yes.
Okay? So far, okay?
Yes.
This one is.
Profe, pues en sí está haciendo el doble.
¿Ah?
En sí está haciendo con casi el doble, ¿no?
Doble.
De x a la menos 2 se va a ir, de x a la menos 1 se va a ir menos 2, de 4 será 8.
Ah, okay. Depends on the function. Yeah.
¿Por qué 8 sin?
What?
¿Por qué 8 sin?
You have the 4.
Ah, ya.
2x derivative is 2 times 4, 8. Cosine minus sine. So that's why you change the sign. Okay. Last derivative. 2x to the minus 3 plus 16 cosine of 2x and again plus what?
3 times 2x to the minus 5 halves.
Very good. This is my final answer, but do I need to rewrite?
Yes.
Yeah. So the real final answer will be 2 over x to the cube plus 16 cosine 2x plus 3 over square root of 2x to the 5th power.
Yes.
And that's the answer. Yeah?
Es que, teacher, cuando tú lo haces en ahí tengo que ir más tres medios.
Ah, okay. Because if we know the derivative of this 2x is 2, and when the derivative of x is half is minus 3 half. Yeah, if you don't see this kind, you add another step to find it. But the answer will be like that. Yeah. See? What's the derivative of e to the x? E to the x. Or in this case it's e to the 2x. So the derivative is 2 e to the because it's the chain rule. By the way, listen, yeah, we're going to do examples. On Friday, the quiz on Friday, this time you won't have a formulary, okay? Oh. No, this time not, because again, if you observe the examples, the functions are not that complicated, unlike the previous ones, but you need to know the formulas by now.
The quiz is going to be
like this, or like the best examples that we're going to do, but yeah, something similar. Good, questions?
No.
Okay, yeah.
¿Por qué se queda cuando se deriva del 2x a la menos 3 medios? ¿Por qué no es 3 sobre 2?
Because, yeah, I skip one step, but the idea here is that since my derivative of 2x is 2, and the derivative of everything is minus 3 halves, 2x is minus 5 halves, the 3 halves and the 2 simplify into just 3. ¿No?
No, o sea que son los 3 medios, pero acuérdate que la derivada de 2x es 2, si la multiplicas por 3 medios te da menos 6 medios. De los 6 medios entre 2 te da menos 3 halves.
el 2x ahí, profe.
Chain rule.
Es la chain rule.
What? Pero después
Sí, pues el 2x.
because that's the inner function. It's like this one, for example. If the derivative of this is 2 times 2 4. Derivative of sine of 2x, cosine of 2x. So you maintain what you had at the beginning. ¿Ya? ¿Por qué se hizo positivo entonces más 3? Because you have más o menos yeah, so you have good. Okay. Listen, now, the idea here will be not just to find the third or derivative. Sometimes I will tell you to find the 100 derivative or the 100 derivative. Okay. If I tell you to find the 100 derivative or something like that, you won't do it one by one. Yeah, you can, yeah, but there should be a way to generalize the derivatives so you can find that big derivative. For example, here, if you observe this one, if you observe this, and then continue, you can observe that it's going to have a certain pattern to the derivative. Or this one, for example, you have sine, cosine, then sine again, then cosine again, and the previous are multiplied by 2. So there should be a way for some of them, not all of them, that you can generalize the derivative. Okay? If I want to generalize the derivative, what I want to find is the end derivative. Okay? So let's do an example.
What?
Okay. Let's say that I have a function, for example, again, e to the 2x. So now we did. Okay. I want to find the end derivative. What does that mean? It means that I want to find a formula. I want to find a formula that generalizes all derivatives. in a single formula. But to really get that formula, you still need to find the first 3 or 4 derivatives to see what happens. This one is easy. For example, I want to find the first 4 derivatives. Y prime would be equal to what?
2x.
Second derivative.
4e to x.
Third derivative.
8e to x.
And the fourth.
15e to x.
Okay. Now, we have the first 4 derivatives, and if you observe, we have a certain parent.
Did you change that?
For those raised to the n power times e times to the 2x.
Very good. Exactly. So, the idea, that's the answer. The idea to get the n derivative is to get a formula that is related to the level of derivative. To the level of derivative, that generalizes all of them. So in this case, for example here, this is the original function. For this one, for example, you have 2 parts. The part with the e and the part with the coefficient, yeah?
Yes.
The part with the e is the same for all of them.
Yes.
But the part with the coefficient is changing. But how? Well, this one is just 2. This one, this 4 is actually 2 to the square times e to the 2x. This one is 2 to the cube times e to the 2x. This one is 2 to the 4 times e to the 2x. Okay? So in this one, for example, if you observe that 2 is this 2.
Yes.
Because it's the one that I'm multiplying with. So how can I generalize this related to the level of the derivative? Exactly. So the formula for the n derivative will be n derivative will be 2 to the n times e to the 2x. So that formula is my n derivative. Because the 2 that is multiplying everything is related to the level of the derivative. 2 to the 1, 2. 2 to the square, 2. 4. 2 to the cube, 8. 2 to the 4 power, 16.
Teacher, but in order to get that one, we need to do the other ones now? Or can we do it now?
We do like 4.
No, in the quiz, for example, you need to find the first 4 derivatives as part of the process. And then, when you get the 4 derivative, if you observe all of them, you come with the general derivative, the n derivative. Okay? So that formula generalizes all of them. And for example, if I tell you, okay, I have that, now tell me, or find the, let's say, 58 derivative. What would you do? Well, you already have a formula. You just have to do it. So it has to be 58 derivative equal to 2 to the 58 e to the 2x. No need to solve this. Just leave it indicated.
Teacher, but for in the second example, is it possible to obtain like a general n derivative to every single term?
Yeah, but you need to be careful on how to represent the sine and cosine. Yeah, but we'll do more examples, okay? So that's the idea. So we're going to find the 4 derivatives and then finding the n derivative to generalize derivatives. And then finding a big derivative like 58 or 100 or something like that.
Profe, ¿cuántas tienes que sacar para poder sacar la fórmula? ¿O con las que con las que
4 will be enough. And yeah, in the exam we'll actually find 4. Good. Okay? Fine. Another example. Can I read this?
Yes.
The question is to find the n derivative and then later the 108th derivative for the function y equal to 1 over x. Okay? Now, let's do it. First, let's find first the first, second, third, and fourth derivatives. No, ln is not the derivative of this. Yeah, we need to rewrite. This is x to the minus 1.
¿Por qué? Porque pasas el X hacia arriba y el y, ¿no? Es un
Right, remember? That's part of the process. Then, first derivative,
Minus x to the minus 2.
second derivative,
No, 2x to the minus 3.
third derivative,
6x minus
fourth derivative. Okay. Now, this one is a little tricky. Yeah, more complicated than the previous one. Okay? The previous one is to see. This one is not so much.
El signo depende si es signo o cual.
Aha. In this case, observe these four derivatives. Which is the or which are the things that are changing within them?
The sign
Aha.
and the number.
The sign,
The coefficient and the exponent.
the coefficient, and the exponent. Okay, so our formula would have three parts. This one has two, the coefficient and the e to the something. This one will have three parts, one for the sign, one for the coefficient, one for the x to the exponent. Okay, so let's go step by step. First, the signs. If you check the signs, this is negative, positive, negative, positive, negative, positive, negative, positive. So how do I put that as a formula? No ifs. No ifs, no words, no nothing. Formula. Okay. Remember, we need to have something that is related to the level of the derivative. So just times 2 is not enough. Y, okay, y squared. ¿Qué es squared?
Cuando es cuadrado o positivo. Este es positivo acá como uno.
No.
So how can I put that as a single formula for all of them?
Que tu n.
Very good. Okay.
Yo no te digo qué.
Minus 1 to the n. Why? Because, for example, remember, the n is the level of derivative. If it was, for example, minus 1 to the level 0, minus 1 to the 0 is what? Positive, right? So, positive. Minus 1 to the 1, minus 1. Negative. Minus 1 to the square, positive. Minus 1 to the cube, negative. Minus 1 to the 4, positive. Okay, so in this case, the power is changing depending on what? Depending on my level, but that level is also the power for the minus 1. So when you have what? When you have odd levels, it will be a negative sign. When you have even levels, it will be a positive sign. Yeah? As soon as you know that when you have a minus 1 raised to an even power, it becomes positive, and it's always negative, right? You know that. Okay, so that's the idea. In this case, this is only for the sign. Minus 1 raised to the level 1, 3, 5, etc. gives you negative. If it's even power, it becomes positive. So that's for the sign. Now, the coefficient. The coefficient is trickier. This is different than this, right? Because it's 2, 2, 2, 2. Almost. How?
X minus n.
No, porque
N to the.
You had the idea. You had the idea.
Lo que no me hago es exponente porque ya
Por el que ya tienes el valor de X.
Por el que tienes el
Podría
valor.
ser X.
O sea, por el anterior.
X por el valor de
O
X.
sea, por algo que n times x por el anterior.
Not x will be the power, but listen. Okay.
N por n menos 1.
Que no se quede
Ah, okay. Yeah. Tell me again. How do I get this one? No, the coefficient, sorry, the coefficient.
Ah, sí. O sea, tener el n por el n menos 1.
For example, this one, you said what? N minus 1, right? For this one?
N por n menos 1.
Okay. You have the idea. Okay. When you have something like this, we need to use a special operation that we use in mathematics. Do you know what factorial means?
No.
When I have factorial, is when you have, for example, a number n, for example, and we're going to put an exclamation sign. That means factorial. But what's that? Doing this, it means that you have that number n multiplied by the previous ones, n minus 1, n minus 2, all the way until you multiply times 1. That's a factorial. I'll give you an example. If I tell you, okay, give me 3 factorial. 3 factorial will be 3 times 2 times 1. Multiply times the integers 1 less until you have 1. And you multiply that. 3 times 2, 6 times 1, 6. If I give you 5 factorial, it will be 5 times 4 times 3 times 2 times 1, which is what? 6 times 4, 24 times 5, 120. Okay? So we're going to use that idea, and we're going to use your ideas to get a formula for the coefficient. How? In this case, for example, this is 1, right? This is what? This is 2 times 1. This is what? This is 3 times 2 times 1. This is what? 4 times 3 times 2 times 1. Okay? I just said, we're multiplying by the previous one. So, in this case, for example, this is the level, factorial. So, the formula for the coefficient is going to be n factorial.
Bueno, pero el 108, 107, 106.
Y luego todo eso raíz a la menos n menos 1.
Wait. But this is the coefficient. Yeah, but.
Para sustituir eso solo ponemos, por ejemplo, 5 factorial y ya.
Yeah.
O sea, no hace falta que pongamos 5 por 4, 3 por 2.
Okay. That's for the coefficient. And then the last part.
Menos n por menos 1.
Yeah. The last one will be x to the what? It's an x, but the power. What's the power?
Menos n menos 1.
Minus n minus 1. Why? Because in this case, for example, this is minus 2, which is minus 1 minus 1 minus 2. Minus 2 minus 1 minus 3. Minus 3 minus 1 is minus 4, and so on. And this gives you the last part, which is variable with exponent. Okay? And that's the formula for the n derivative of this specific function.
Ay, profe, ¿por qué no haces
Okay?
La verdad no entendí, pero bueno.
Lo triste es que no hay. Sí, existen las materias todavía.
We'll do more examples, okay? Fine. So, if I want to find the 108th derivative, would be what? Just put the value. Minus 1 to the 108 times 108 factorial x to the minus 108 minus 1. And then we try to solve and rewrite. But we're not going to solve the 108 factorial. It's a really, really big number. We're just going to try to simplify what you can. For example, minus 1 to the 108, it can be done. What's that? 1. So it's positive. So that means that is 108 derivative will be positive 108 factorial over, because it's negative, x to the 109 power.
¿Y cómo se dice
That's it. Questions? No, perdón. Minus 100 minus 1 is minus 109. So it is right. You're right.
¿Y alguna manera de poner ese factorial en la calculadora?
Yes, but if you were to put 100 factorial, the calculator is going to give you an error because it's too big of a number. But there's a way, but no, just leave it indicated. Actually, for example, next semester in Math 6, in Toma de Decisiones, no calculus, we're going to see factorials.
Yes. No quiero que ponerlo.
Okay, one more example. Can I erase? Can I erase?
Yes.
Yeah? Okay. Ready? Okay, last example. Something like this is going to be in the exam.
Oh.
In the part
I'm giving you an example like the quiz. So, again, find the n derivative, find the 37 derivative. What's the only difference? You have a plus. No difference. We have two formulas, one for the e, one for the one that we got from the other.
Minus 6 e.
Derivative minus 6 e to the minus 2x. Derivative of this?
2 over x.
2 over
1 over x.
El 2.
2x derivative?
2.
And then 2x derivative? 1 over 2x. Same thing.
2x.
No tenemos que escribirla porque ahí
Es cierto.
What?
¿Reescribir qué?
la función.
No. Remember, the antipower is fine. You could rewrite that one, but only in chain rule. Ya le sé esta otra canción.
Ya caché.
Okay. Second derivative. 12 e to the minus 2x minus x to the minus 2. Third derivative minus 24 e to the minus 2x plus 2x to the minus 3. Fourth derivative 48 e to the minus 2x minus 6x to the minus 4. Okay, that's the fourth derivative. Now, n derivative by parts, one for this, one for that. First for the exponential part. You have plus minus plus minus plus. Minus 1 to the what?
To the end.
To the n. Then you have this 6, 3, 6, 12, 24, 48. So it's going to be again 2 to the n.
No, esa es factorial.
No, in this case not factorial. When you have e, it's not factorial.
But there would be an exception.
2 to the n.
2 to the n.
No. Listen.
N times 6.
No. It's even easier. Yeah. It's just 3 times 2 to the n. Why? Because this 3 at the beginning. But then you have 6, which is 3 times 2 to the 1. 3 times 2 to the square. 3 times 2 to the cube. And so on. Yeah? So that coefficient at the beginning is part of my formula. And the rest is by applying the derivatives. Times e to the minus 2x. Okay? And what parentheses? Yeah? So again, the only difference between this one and the first example is that you have an initial coefficient. Because this is 3 times 2. This is 3 times what? 3 times 4, which is 2 to the square. This is 3 times 2 to the cube. This is 3 times 2 to the 4th power, and so on. Just remember that when you have into something, it's the number to n. Always. Now, for the second one, for the other one,
You could put plus and again minus
Plus?
to the n.
in this case again, first the sign plus, plus, minus, so it's going to be
Minus 1 to the n.
minus 1 to the what?
No, porque ya está al revés.
Minus n.
No, porque si no sería como la otra, si no
N plus 1.
Oh, Jesus.
Y n plus 1. Because for example, again, it's minus 1. That's a given because you change the sign. But the level, here the level is 1. If I add 1, it becomes 2. And minus 1 to the square becomes positive. When it's 2 plus 1 becomes 3. Minus 1 to the cube now is negative. And so on. Times what? Now, careful, coefficient 1, coefficient 1, coefficient 2, coefficient 6. Second is a factorial, but what kind of factorial? Just n factorial again?
No.
Porque va 2 y luego va a ser.
So, it's going to be
2n.
N minus 1 factorial.
Why? Because again, this one is 1, this one is 1, but this one is 2 times 1. This is 3 times 2 times 1. So it's this level minus 1 together with this
¿Pero
level.
por qué n menos 1? ¿Por qué n menos 1?
Ve los niveles. N es el nivel.
Ajá.
Y por ejemplo, el nivel es 1. Si es 1 y le resto 1, se vuelve 0 factorial. 0 factorial es 1, siempre. 0 factorial es 1. Siempre. Entonces, está bien. Siguiente, 2 menos 1, 1 factorial también es 1. 3 menos 1, 2 factorial, eso es 2. 4 menos 1, 3 factorial es 6.
Por X de la primera serie.
Oh. Sí, sí, sí.
No entendí nada. ¿Cuándo hay historias, profe?
Questions about this? Now, then what? Derivative will be minus 1 to the 27 times 3 times 2 to the 27 e to the minus 2x plus plus minus 1 to the 28 times 26 factorial x to the minus 27. And simplify. Minus 1 to the 27 is what? Minus. So it's minus 3 times 2 to the 27 over e to the 2x.
Perfect.
Minus 1 to the 28 is plus 26 factorial over x to the 27. That's the answer. No. Ok. Yo sé que se ve complicado, jóvenes, yo sé que se ve complicado, pero vamos a poner ejemplos como estos en el examen. Por lo menos estudien qué pasó, que vean qué pasa con esto. Mañana, actividad 3.31. Se la traigo.